we are working with measurement. We finally started measurement. We have measurement today and then Tuesday next week, and then we finish off with maps and plans. So we've got 3 lessons to go. But let's get stuck into the measurement questions already. We're doing conversions and 1D calculations tonight, one-dimensional calculations tonight. So here is the first measurement question. And if you guys have a look at it straight away, you can see it's an ingredients list question. These often come up in exams, and it's part of the conversion section of measurement. So we have a recipe here for cooking ostrich. I don't know how many of you have had ostrich, but here's a recipe for ostrich fillet and nachi sauce. Sure. All right, so there's all the ingredients over there. I'm just looking at the ingredients and I'm seeing pounds and ounces, and I don't see. I'm sure there's a conversion here somewhere. Maybe we don't need it. I don't think we're going to need it anyway. So we've got imperial and we've got metric units in this ingredients list. We've got pounds and ounces there, and then we've got milliliters here, which is the metric system. The yellow ones that are highlighted are the imperial system. So if you see these two different units in one question, they could ask you to convert. But quick glance at the questions here. Didn't see any questions asking about that. But usually, if they have imperial and metric in one ingredient list, they often ask you to convert between the two. All right, but no questions about that this time. So let's see what questions they do have. There's question 1. It says, while Gretchen is preparing the recipe, the only measuring spoon that she has is a 5 milliliter teaspoon. The recipe requires 2 tablespoons of olive oil. All right, we're looking at the 2 tablespoons of olive oil. So when they say TSP, that's a teaspoon. If they say TBSP, that's a tablespoon. All right, so if they don't tell you in the question, now you know. All right, TSP is teaspoon and TBSP is tablespoon. She's only got a 5 ml teaspoon. The recipe requires 2 tablespoons of the olive oil. How many teaspoons of olive oil will she use if 1 tablespoon is 15 milliliters? How many teaspoons will she have to use for 2 tablespoons of olive oil? That's what they're asking. How many teaspoons for this amount, 2 tablespoons of olive oil in here? I'll give you guys a couple of minutes to try that one out. Okay, so we need to measure out 2 tablespoons of olive oil, but this person only has a teaspoon, a 5 millimeter teaspoon to measure with. So how many of these teaspoons will we need if 1 tablespoon is 15 milliliters? That's the question. Give you a couple of minutes and then we'll go over it together. Shouldn't take you that long. Try that one out. How many teaspoons must she measure out? All right, good, Kayan, good. Any other answers there? You guys try it yourself. Yes, Kayan, that's correct. All right, so we got an answer of 6. Let's see how we do that. So we're gonna take our, yep, you guys are on the money. So let's take our tablespoons and see how many teaspoons we can get. Yes, all right. So we know that 1 teaspoon is 5 milliliters, but we have 2 tablespoons. All right, and we know that 1 tablespoon, like it says there, is 15 millimeters. So this is going to give us 2 times 15 milliliters. That gives us 30 milliliters. All right. So all we have to do now is see how many teaspoons are in there. So we're going to take our 30 milliliters and divide by 5 because each 5 is a teaspoon. And we see we have 6. So 6 teaspoons will get us the olive oil that we need. Very good. Not bad, nice and easy. Not a bad one to start with. You guys have done well. All right, let's carry on. Let's see what question's next. There we go, number 2. How many cans of nard cheese will be used if Gretchen prepares the recipe for 20 people? Now I'm going to take this question and bring it up here. How many cans of nard cheese if we're preparing for 20 people? All right, there we go. There's the recipe and there's the question. How many cans of nard cheese do we need for 20 people? Off you go. Should take you about a minute to do that one. How many cans of nard cheese for 20 people? All right, you should all be putting answers in the chat or putting a thumbs up. How many cans of nard cheese for 20? All right, there we go. Yep, good job. Good job. Okay, hope you guys are all trying this. Okay, we know that this recipe serves 4 people and we need 1 can. Okay, so if we want to serve 20 people, how many cans do we need? Well, you could say to yourself, from 4 people up to 20, what do I need to do to go from 4 to 20? Well, you can multiply by 5. And you need to do the same for the cans. You need to multiply by 5 to get 5 cans. All right. So 4 times, whoopsie, 1 can times 5. It's 5 cans. And how did we get that? Because we said there are, for 20 people, I have to get the 5, you can say divide by 4, that'll give you 5. All right. Yep, that's it. Easy, easy, easy 2 marks. Easy 2 marks. Well done. Good job. All right, let's look at the next question. Here we go. Let me bring this answer down here. Stick it down here, and then we'll have a look at question 3. All right, here we go. Question 3. According to the recipe, Gretchen has to preheat the oven to 400 degrees Fahrenheit. Her stove's temperature is in degrees Celsius, and she sets it to 220 degrees. Show by using the formula whether she used the correct temperature. Did she use the correct temperature? Show if she did. All right, there's the formula. Okay, that you need to use. She needs to get her oven to 220 degrees. So show by calculation if she used the correct temperature. Be very careful. You got to give your answer to the nearest 10 degrees. Right, so we're going to do the calculation and check. Okay, so you guys should be able to do the calculation and then let me know. Did she use the correct temperature by setting it to 220 degrees? Is 220 degrees enough? Too much, too little? Is it good? Is 220 degrees the right temperature? All right. You should all be trying this one. All right, there's the question on the screen. You guys try it. Okay, so you guys are coming up with answers already. Okay. All right, good. Excellent, excellent, excellent. Okay, good. So you guys have said that we need to use the formula and to find out what degrees Fahrenheit she is going to have if she uses 220 degrees Celsius. We're going to put that into the formula at degrees C. All right, we'll put in a 220 at degrees C there. So 220 goes in over there. And let's see what she gets. All right. We need to multiply it by 1,8, and then we need to add 32. So 220 times 1.8 plus 32 gives us 428 degrees Fahrenheit. Now, the question said we have to give our answer to the nearest 10 degrees. So we have to look at this 2, right? And check if it changes. And because there's an 8 next to it, this should give us 430 degrees Fahrenheit. If we round that off to the nearest 10, then the question says, according to the recipe, she has to preheat the oven to 400. Show whether she used the correct temperature if she used 220. So she used 220, I got 430 degrees Fahrenheit. So did she use the correct degrees Celsius for this? Well, she's supposed to get 400. So the answer is no. She's not done the right setting here. No. Her temp, sorry, her temperature is too high. You see that? Yeah, it's all right, Karen. Don't stress. The temperature's too high. We go up to 428 and round off to the nearest 10, we get 430. She needs 400. So she's too high. Can you guys see that? All right. You guys see that? I hope you guys can all see that. Please, if there's any questions, you've got to speak to me. All right, you got to talk. Raise your hand, use the raise your hand function in Zoom and speak to me. Are you guys all happy with this? How we did it? All right. If not, please raise your hand and we can go through it again. But we can see here that she's too high. All right. She's way too high. She needed 400. She got 430. All right. Let's move on. Let's see. Here we go. Here's another scenario. In South Africa, meat is sold in kilograms. Convert the ostrich fillet needed for this recipe to determine how many kilograms of ostrich fillet Gressim has to buy. Give your answer to one decimal place. All right, so finally we get to this conversion. I was worried where this question is. And here we go. Here are the conversions for this. Now, what I'm going to do is bring the ostrich meat weight down to this question. So if I go up to the recipe, it says 1 pound, 2 ounces. 1 pound, 2 ounces. So I'll write it over here. 1 lb and 2 oz. 2 oz for ounces. So that's how many pounds and ounces of meat we need. They want to know how many kilograms is this? And this is 5 marks, eh? 5 marks here. Interesting. And we've got to give our answer to one decimal place. Now, ladies and gentlemen, when they put this in a question, give your answer to one decimal place. Your answer and your rounding needs to be accurate. Okay. Who would like to tell me how we even going to try this one? Is there anyone out there that's going to help me out? What are we going to do? How are we going to try this question? What should we do here? Is there anybody? Nobody?
Is
Right,
there
Dina, so
somebody?
is there somebody? Uh,
Anybody?
anybody? We need to convert the imperial weight of the ostrich, which is underlined here. 1 pound, 1 lb, and 2 ounces. They gave the recipe in imperial measurements. We need to convert this to metric, which is kilograms. Okay. And they say you can use these conversions over here on the left to help you do that. So we got to convert 1 pound and 2 ounces into kilograms. And then don't forget that the last part of the question says round your answer off to one decimal place. Is there anybody that can help with this? Where do we begin? What do we do? All right. Dina, just check your screen there. You should see a little prompt. There we go.
Good evening, sir.
Good evening, young gentlemen. How are you? You all
Good
good?
things in yourself, sir.
I'm good. What do we do here?
Yeah. Sir, I'm not really sure, sir, but I think the first few steps we're gonna start by converting. We're gonna start with the pounds, and
Yep,
then we're gonna a pound times the conversion.
very good. So 1 pound times 0.45359 will get us 0.45359 kilograms. Good. We've changed the pounds.
Yes, sir.
Now we need to change the ounces, but the only conversion they give us is from
And
ounce.
then I think we do the same thing.
Let's do the same thing with the ounces, but we're going to use the conversion they gave us. So 2 ounces times 0.0625. Now, yeah, and this is why Kia always says show your units, because I'm sure that when you guys do this and you don't show units, that you might leave. For example, if you didn't write units here, okay, and you did both of these conversions and you got these two numbers here, I'm sure if you didn't have conversions there, you might think, well, they're both being converted to kilograms, let's add them up. But if you have your units in place, you will see the top one is in kilograms. The bottom one, if we look at the conversion over here, ounces, this conversion takes you to pounds. So this second one here is not kilograms, that's pounds. So we can't add
Yes,
those up
sir.
yet. So what do we do in DOA? We've got to keep going.
We're first gonna convert it from ounces to pounds, and then we're gonna convert it from pounds to kilograms.
Absolutely. On the money. All right,
So
zero.
we're gonna say 0,125 times 0,45359.
That's it. Exactly that. 0.45359. And this gives us, oh, yeah, horrible looking decimal. 0.056698, 0.056698. I'm going to write all the decimals, 75. And this is in kilograms. Okay, so now these two can be added up. We can now put it all together. So I'm just going to copy and paste here because I'm lazy like that. And add up the kilograms. Okay, so we add these two together, and then you should get your final answer in kilograms from there. So let's do that. So I'm going to take what's on my screen and just add it back to the 0.45359, and that gives me 0.510288750, 0.510288750. 5,102 over 105 kilograms. All right, and Dewey, are we done?
No, sir.
What do we have to do still?
We have to take the final answer and then round it off to the
How many?
last decimal place.
They say here in the question, round the final answer to 1 decimal place. So in
Yes, to
our
one to.
yeah, so in our number, we're looking at this first decimal, which is the 5. Will it change?
No, sir.
No, shame. You're tired. You're studying hard. All right.
Hey,
So
sir. Hey,
yeah, you sound
it's a
sick as
must,
well.
sir. Hey, we have to.
You have to. Last push, guys. Last push. You're nearly there.
Uh,
0, 0.5 kilograms is
Yes,
the final answer. Dewey, thank you so much for your help. I
yes.
appreciate it, man. Thank you.
No problem, sir.
Okay, there we go. So we converted the pounds first. Step number 1, we converted the pounds first. Step number 2, we converted the ounces to pounds. Step number 3, we converted those pounds to kilograms again. And then number 4, we added them up and rounded off. All right, there's your 5 marks. So a 5-mark question like this looks big in the beginning, but if you start the process off bit by bit, you finally get there. Okay. Any questions about this? We all good? We all good? Everyone all right? Awfully quiet out there. It's like crickets. All good, all good, all good. If not, speak now. Don't ever hold your peace. Alrighty. Next question. Here we go. We're dealing with time now. During the holidays, Peter spent 2 hours gardening. He spent 45 minutes mowing the lawn, 20 minutes trimming the edges, 30 minutes weeding, and the remainder of the time watering the flowers. What fraction of the time, in the simplest form, did Peter spend mowing the lawn? Oh, Keon. 2.5. Eesh. It couldn't be Matlet. There must be something else. Horrible. What fraction of the time did Peter spend mowing the lawn? Mowing the lawn? Hmm. Mm. Sorry, guys. I'm sure you're very tired and you've got to come and stay here with me. But we got 25 minutes left. All right, so let's try to do as much as we can in preparation for your final exams that are coming. Okay. So what fraction of this time did he spend mowing the lawn? So we have 2 hours in total, and mowing the lawn was 45 minutes. Oh, well, clearly I'm sorry, man. I feel for you guys. It's not nice. It's not nice. But you got to hang in there. Hang in there. Rest where you can. Work hard and rest where you can, hey? Work hard, rest where you can. All right, so what fraction, in simplest form, did Peter spend mowing the lawn? All right, let me help you with this, guys. Let me help you. So first of all, we've got 45 minutes of mowing the lawn and 2 hours in total of doing gardening. Now, I don't know if you can see, but it keeps coming up over and over again. You got to make sure your units are the same. You got to work with the same units, right? We got minutes on the right-hand side. We got hours on the left. We can't have that. So we're going to change our 2 hours, first of all, into minutes. We multiply by 60 and we get 120 minutes. Now we can work with this. So what fraction out of the gardening did he spend mowing? It was 45 minutes out of, almost said 60, 120 minutes. And the fraction needs to be in its simplest form. Yes, so we need to put that fraction in our calculator, and the calculator will do all the work for us. So put it into the fraction in the calculator, pressed equals, there we go. Well done, Keon. 3/8 in its simplest form. Okay, look at the next one. What fraction of the time in its simplest form did Peter spend watering the flowers? Watering the flowers. Ah, here we go. Watering the flowers is the remainder of the time. the remainder of the time. Oh, so you got to do a little bit of work first. They don't just give you how much time he spent watering the flowers. You're going to have to do some calculations first to get that time. So what you have to first work out how much time was spent watering the flowers. So let's take our 120 minutes and take away all the other things, which are the 45 minutes for mowing the lawn, 20 minutes for trimming, plus 30 minutes of weeding. We're taking out all three of those things. Let's take it out. So 120 minus, I like to use brackets. You don't have to. 45 plus 20 plus 30. And we're left with 25 minutes. Now, if they just gave you the 25 minutes, that's easy. You just throw it into the fraction. But they didn't give you the 25 minutes. They made it a little bit more complex for you, but you guys can handle it. So it's 25 minutes out of 120. Put that on our calculator. And there we go. 5 over 24. So there's an extra step involved here. Yes, Keon, well done. Extra step involved here. We had to work out how much time was spent watering the flowers. We took the total, removed all the other times, and we were left with the flower time, and then put that into the fraction. All right, not too bad. Not too bad. Let's see what they got next. Oh, yes, I love it. Speed equals distance equals speed times time. Oh, I love these questions. All right. Peter and a lady went to George with their parents during the holidays. Excuse me. It took them 6 hours to travel 461 kilometers from Kings William Town to George. The car's petrol tank was full when they left Kings William Town. When they stopped at George, the tank was filled up with 31.17 liters. First of all, question number one, what was the speed of the trip? Give your answer to the nearest kilometer. Phew. These people are fussy with their decimals tonight. What was the average speed of the trip? Use the formula distance equals speed times time. Now, this is not very fair. They say, what's the speed? And then they give the formula with distance. All right. Well, we know the formula, right? It's a little triangle. You should all know it. Speed equals distance over time. So don't worry about the formula they give you. You keep working with this one. Because look here, they give you the wrong one. All right. We need speed. Okay. So this thing says if you want speed, you got to put D over T. You got to put distance over time. To get speed, you got to put your distance over time. All right. Let's just confirm using this triangle how they got theirs. If you want D, all right, if you want D, you got to say S times T. Okay, so with this little triangle, you can work out any of these. You don't need their formulas. So we're not going to work with distance equals speed times time. We're going to work with speed equals distance over time. So to get our speed, S, we need to take our distance, which is 561 kilometers, and put it over our time, 6 hours. Now, ladies and gentlemen, again, showing units, right? If you give this formula kilometers and hours, your speed will come out in kilometers per hour. If you give it kilometers and minutes, your speed will come out in kilometers per minute. If you give it to meters and hours, it'll come out as meters per hour. So whatever you give this formula, that's what it's going to give you out. Okay. What you put in is what you get out here. All right. So let's go to the calculator. 561 kilometers, and this was done in 6 hours. So the average speed was 93.5 kilometers per hour. Is that what they want? Let's check. What is the average speed for the trip? Give your answer to the nearest kilometer. All right, so we're going to whole kilometers here. So we have to look at this 3, and this must be rounded off to 94 kilometers per hour. Okay. All right. You all getting that? Yandina, we got to divide, hey? have to divide here using this formula over here. So we're not going to use their formula here because you see, Indina, their formula here, the question says, what is the speed? So it's speed that we're trying to figure out, but that's on the right-hand side here. We want speed on the left. So this formula they gave you, you would have to rearrange it to get speed by itself. So I've done that on the right-hand side here, speed equals distance over time. So that's the one we're using here. Okay, so yes, we have to divide. All right, don't worry about the formula. We have to get speed S by itself here. So that's why we're doing distance divided by time. All right, and running off to the nearest kilometer per hour. Okay, let's see what else they got for us. Here we go. Calculate how far they traveled on 1 liter of petrol. Give your answer correct to the nearest kilometer. Now, I'm going to bring this up. I'm going to erase all this and make space here to squeeze this in over here. All right, so I want to put this over here. There's the question. Question 2. Calculate how far they traveled on 1 liter of petrol. Give your answer to the nearest kilometer. Okay, and Dina, let me, while you guys are trying number 2, I'm just going to explain, yeah? So Indina, they said they wanted speed. All right. But they gave you a formula like this. They said distance is equal to speed times time. All right. So this formula that they gave you is going to give you a distance answer by multiplying speed and time. That's not what we need. We need something like this. S equals something and something. Right? So either you have to take their formula they gave you and move things around, which you can do on your own like that, or you can remember the diagram to find what you need. So the diagram says speed equals distance over time. So if you look at this diagram here, to find speed, S, we need to put distance over time. So their formula isn't wrong. It's just not arranged the correct way for us to find speed. That formula they gave you is finding distance. We need to find speed. So we have to use the formula rearranged in a different format. Okay, so this is the formula S equals D over T that we'd have to use for this question. So be careful with that. Often they do give you the formula in the correct format, but in this case, they didn't. So we'd have to rearrange it, okay, to get what we need. All right, I hope that makes sense. All right, we got answers coming through. I hope you guys are all trying this. How far on 1 liter of petrol? Give your answer to the correct to the nearest kilometer. How far on 1 liter of petrol? Nearest kilometer. Nearest whole kilometer. Nearest whole kilometer. Okay, we've got the car traveled 561 kilometers and it used 31.17 liters of petrol. So how far for 1 liter of petrol? You should all be trying this one. If 561 kilometers takes you can be done on 31.17 kilometers, how far will you travel on 1 kilometer? All right, good. The answers are coming through now. Very good. Well done. That's it. Even though you guys are tired and you're not in the mood, you're still putting in the effort. Very good. All right. So if we look at this little sketch that I've drawn here, to get 561 kilometers, you need to put in 31.17 liters. So how many kilometers for 1 liter? So what do we do to this 31.17 to get it to 1? Well, we can divide by 31.17, but we must also do that on this side. All right. So 561 kilometers divide by 31.17 liters. And that gets us, like you all have tried, 561 divided by 31.17 is 17.99807. 17.99807 kilometers per liter. But they want you to round off to the nearest kilometer, a whole kilometer. So obviously this is going to go to 18 kilometers per liter. Okay, you guys have got. Ooh, why are we getting different answers, guys? Am I doing something wrong here? 561, 31.17. 561, 31.17. Guys, why are we getting different answers? Why are we getting 17.7? I'm getting 17.99. What happened? I'm looking at my calculator there. I don't know why we're getting 17.7, guys. Ah, don't worry, Kian. Looks like a lot of other people made the same mistake. All right. So, yes, we're getting 17.998, and that needs to be rounded off to the nearest kilometer. So that you're looking at this 7 here. Will it change? Yes, the 9 behind it will push it. That's all right. Don't stress, Keon. Don't stress. Human error. It happens to all of us. All right. I hope you guys see that. I hope you're all good. Did you all see that? Any questions? How are we doing out there? Are we all okay? Hope we're all okay. We're nearly done. We've got 13 minutes left. All right. Stay with me. So what I'm going to do is I'm going to take this answer. Whoopsie. And put it down here and have a look at number 3. All right, here we go. Good. Number 3 says, calculate the cost of the petrol. If you guys, this must have been an old paper. This must have been a very old exam paper. Look at the price of this petrol. 10 Rand and 5 cents. My word. I don't know if you remember those days, but I remember those days. Long, long, long time ago. Calculate the cost of the petrol if the petrol price was 10 Rand and 5 cents when they filled up in George. How much did it cost them to fill up in George? Whoa. It took them 6 hours to travel. The car's petrol tank was full when they left Williamstown. When they stopped at George, the tank was filled with 31. Calculate the cost of the petrol if the petrol price was 10 Rand when they filled up. Careful now. This is not. Ooh, careful. All right, I'm going to let you try this on your own and let's see. Try it on your own, please, ladies and gents. Let's see what we get. I'm interested to see what answers you get here. How much was the petrol? Calculate the cost of the petrol if it's 10 Rand and 5 cents a liter when they filled up in George. When they filled up in George. Calculate the cost of the petrol. All right, we're getting answers. Anyone else out there? Just try it yourselves, guys. Try it yourselves and then put an answer out there. We'll check as soon as we get some more answers. We'll check. Anybody else out there trying this? Come on, ladies and gentlemen, you should all be trying. How much was the petrol? It's 10 Rand and 5 cents a liter. When they filled up in George, how much did they pay? Is there anybody else trying? I'm sure you guys are all trying. Leader's got an answer there. Good. Come on, there's a couple of people with answers. We should all be trying this. Come on now. Viwe, you're not keen tonight, eh? Viwe's just relaxing and watching us. It's okay, Viwe, don't stress. Exams are stressful. It's okay. Exams are stressful. As long as you're watching, it's fine. It's okay, baby. Sorry to embarrass you. All right, moving on. Let's check it out. We're getting answers here. Let's try them out. Calculate the cost of the petrol. If the petrol price was 205 cents a liter, they should have said here per liter when they filled up in George. All right, so first of all, how much petrol did they put up in George? Now, some of you might have worked out for a full tank, but we know that they only put in 31.17 liters of petrol in George. So that's the amount of petrol that we got to work with. So it's 31.17 liters, and each liter costs 10 Rand and 5 cents. So it's 31.17 times 10.05. 3132585. 3132585. 3132585. And obviously we're going to round this off. They didn't give us an instruction, so we will round off to 2 decimal places. We will look at the second decimal, and will it change? Yes, it will. So 313 and 26. Am I making a mistake here? Guys, I think all of you that put your answers out there might have made the same human error. Same human error. All right, check your answers. There's my answer on the calculator. 2585. 2585. Okay. So yeah, don't worry, Keon. Looks like everyone's making the same mistake. Don't stress. Don't stress. Everyone else is making the same mistake. All right. Let's move on. We're going to do one or two more and then we'll call it a night. I think we're all tired. Yes, I know. I know there's a lot going on. Don't stress. All right, let's have a look. Let's have a look. Let's have a look. Let's have a look.